Hi girls, this video is looking at rational functions. Okay, so it says the rational functions we consider in this course can be written in the form y equals ax plus b over cx plus d. These functions have asymptotes, which are horizontal and vertical lines. And we're going to look at how to find these asymptotes as well today. So a reciprocal function is a function of the form k on x or fx equals k on x, where k does not equal 0 and is a constant. So the simplest example of a reciprocal function is just 1 on x. So here's a picture down here. Okay, so there's y equals 1 on x, and we've also got the lines y equals x and y equals negative x. So you can see that along the line y equals x, the function is symmetrical. And along the line y equals negative x, the function is always also symmetrical, as the two parts are symmetrical, like are mirror images of each other along the yellow line. Okay, so the graph of y equals fx equals 1 on x has two branches, as you can see. Fx equals 1 on x is undefined when x is 0, because that's also when the denominator equals 0. The graph of fx equals 1 on x exists in the first and third quadrants only. So remember, this is the first quadrant and this is the third quadrant. And also this is the second, which is not where the function is, and this is the fourth, which is not where the function is. Fx equals 1 on x is symmetrical about y equals x and y equals negative x, so we've already talked about that. Now, as x approaches infinity, in other words, as x goes to the right, fx approaches 0 from above. So in other words, the function is moving downwards towards this, towards 0, towards y equals 0. As x approaches negative infinity, which is to the left, the function again approaches y equals 0, but from below. As x approaches 0, in other words, towards the y-axis, so in here, the function approaches positive infinity, so it's going up forever. So it's approaching a y value of positive infinity. But as x approaches 0 from the left, the function goes downwards and approaches negative infinity. And the asymptotes of fx equals 1 on x are the x-axis and the y-axis. So it's the x-axis because that's when x equals 0, so the denominator is 0, so the whole function is undefined. And it's also, so that was the y-axis, and it's also the x-axis because the function approaches 0 as x approaches negative and positive infinity. But we never quite hit the x-axis, we never quite hit 0, which is why it's an asymptote. Okay, so now, this is all from the textbook, but I'm also going to explain it in a different way. So first of all, now we're looking at the graph of the form y equals ax plus b over cx plus d. The graph of, this is an example, the graph of fx equals 2x plus 1 over x minus 1 is shown below. So what do we notice? We notice we have a vertical asymptote at x equals 1. And that's because that's when the denominator equals 0. So when x minus 1 equals 0, move the 1 over and we get x equals 1. So that's the vertical asymptote. Now look at this asymptote here. Here's the horizontal asymptote of y equals 2. Now, there's a couple ways to find that horizontal asymptote. You could graph the function on your GDC and just trace it and see what happens as x gets bigger and bigger. So trace it to the left and right. You could use a table of values, so that's also in my iBook, so please look at that to find it. Or, girls, there's actually a little bit of a cheat, okay? Basically, if you look at any function, the asymptote, so let me just write it down. So here's our function, fx equals 2x plus 1 over x minus 1. Now hopefully you know that x down here has like an invisible coefficient of 1. So basically, girls, you can find the horizontal asymptote of a rational function by looking at the coefficients of x. So here we've got 2 and 1, or 2 over 1, which means the horizontal asymptote is y equals 2 on 1, or in other words, y equals 2. That's kind of a cheat to use for finding the horizontal asymptote. So here's another one I'll give you. Y equals 3x minus 4 over 6x plus 2. Again, just look at the coefficient of x on the top and the coefficient of x on the bottom. Therefore, the horizontal asymptote is y equals, it's always y equals for the horizontal, 3 on 6, or in other words, a half. And you can check that by graphing it on your graphics calculator. Now, girls, let me also do a different example, such as y equals 7 over 3x minus 1. Well, you're probably thinking there's no x term on the top. So what do? Well, think of it this way. It's kind of like 0x plus 7. Okay, because that's the same, 0 times x is just 0, so it kind of goes away. So it still equals 7 on 3x minus 1. So you could think of the horizontal asymptote as being like, 0 over 3. So the horizontal asymptote is actually y equals 0 on 3, or in other words, just 0, y equals 0. So that's kind of a cheat way to work out the horizontal asymptote whenever you have a rational function or a function in a fraction. That's what I mean by that. Okay, so that's an easy way to explain all of this. So don't worry too much about what it says there, because we found a different way of finding the vertical and horizontal asymptotes. So for the vertical asymptote, you find when the denominator equals 0, and that'll be the x equals something asymptote. And then to find the horizontal asymptote, you use the coefficients of x in the numerator and denominator and make it y equals that, and that'll be your horizontal asymptote. Now, here they talk about sign diagrams. So from here, the sign diagram of y equals 2x plus 1 over x minus 1 is, okay, let's just talk about that. Why is it that? Basically, they've found the x-intercept at -1/2, which is there, and the asymptote at x equals 1, which is there, which is why there's a dashed line on top. And then they check the sign of the function. Let's check that it's correct for that diagram. Okay, so when we're less than 1/2, we are above the x-axis, so it is positive. When we're in between 1 and 1/2, we're below the x-axis, so it is negative. And when we're bigger than 1, we're above the x-axis. So that makes sense, it is positive. Okay. And this can help us work out where we are in regards to the vertical and the horizontal asymptotes. Now, this part here is about the horizontal asymptote. Now, we've got our cheat way, so we're going to stick to that. Okay, so to determine the equation of a horizontal asymptote, you consider the behavior of the graph as the function as x approaches infinity. So basically, their way of finding the horizontal asymptote was to substitute large numbers. We've covered that in class, and you get approximately 2. And that's how you know the horizontal asymptote is approximately 2. But now we have a cheat way, which I wrote here. To help find the horizontal asymptote, use the coefficients of x in the numerator and the denominator. Okay, so now we're going to try and consider the function y equals 6 on x minus 2 plus 4. Find the asymptotes of the function. Okay, so for part A, let's consider the vertical asymptote first. Okay, so that's when the denominator is equal to 0. So that's when x minus 2, which is the denominator, equals 0. So that's when x equals 2. So that is the equation of the vertical asymptote. And what does that look like? Well, let's draw it. So at 2, we should have a vertical line at x equals 2. Reminder, because it's x equals 2, we go through the x-axis, which we did at 2, and that's how you know it's a vertical line. Okay, now let's consider the horizontal asymptote. Now this is an interesting one. It's y equals 6 on x minus 2 plus 4. Now there's a couple ways you could do this. You could try to make it all one fraction and then do it the way we were talking about before, or we can leave it as it is. Let's just consider this beginning part first. So what was our cheat? We pretend there's like a 0x on the top, and there's an invisible one in front of this x. So usually we would say the horizontal asymptote is 0 on 1. But we've got to remember we've got a plus 4. In other words, we're shifting up 4. So whatever the horizontal asymptote would usually be, which in this case, like for this graph here, for this fraction, it would be 0. Now we also need to shift it up by 4 or add 4. So it becomes 0 plus 4, or in other words, 4. So that there is the horizontal asymptote. Now it's important to also remember, girls, if I want the asymptote, I want an equation. So you can't just have 4 as your asymptote. It has to be y equals 4. Otherwise, you're not giving me the whole equation. So that tells me I have a horizontal asymptote at y equals 4. Now what I should be doing with these is labeling them. This one's y equals 4, and this one's x equals 2. Okay. Now it says find the axes intercepts. So I might do that over here. So how do you find the x-intercept? That is when y equals 0. So if you sub 0 into the equation, you get 0 equals 6 over x minus 2 plus 4. I might move the 4 over and get 6 over x minus 2 equals negative 4. Now I'm going to flip both sides and get x minus 2 over 6 equals negative 1 on 4. Because remember, 4 is like over 1, and you can flip both sides. Times both sides by 6, I get, cancel. I get x minus 2 is negative 6 on 4, or in other words, negative 3 on 2. Add 2 to both sides. X equals, it should be a half, I believe. So my x-intercept for my function is like at a half, so it's about there. Okay? And now for the y-intercept, that's when x equals 0. So that's when y equals 6 on 0 minus 2 plus 4. So that's negative 3 plus 4, or at 1. So my y-intercept is there. Now, since I know what generally happens with an asymptote, I already know what this function looks like. I know that if I have to hit the intercepts, then I'm going to be going downwards towards negative infinity. Because now you can check that by choosing x values really close to our vertical asymptote at 2. You could sub in 1.9, you could sub in 1.99999, so you're getting really close to 2. But hopefully you realize that whenever we get close to a vertical asymptote, we're either approaching positive or negative infinity. So given that we're going in a downwards direction from the y-axis to the x-axis, it makes sense that we would continue this downwards motion and go to negative infinity. Okay, so then if that's that shape, then clearly we're going to be going upwards. But wait a minute, we've got another horizontal asymptote, so we're just going to approach this asymptote and go in that direction. If you're not sure about that, sub in x values like -6 and -8 and even like -20. And you'll see in your calculator that we get close to 4 but don't quite pass it. However, you do need to have an understanding and be able to do it without your calculator, just in case it's a non-calculator test. Now, generally, this is symmetrical in the other quadrants, so we expect this one to be approaching infinity up here, positive infinity, and approaching 4 from above here. Now, what you might do is sub in something like 4 just to plot 1 point on this side. So I might do that down here. When x is 4, I get y equals 6 over 4 minus 2 plus 4, which is 6 on 2 plus 4, which is 3 plus 4, which is 7. So now I know the point 4, 7 lies on my graph. So that must be 4, then 7 is about there. So now that I have 1 point, I can pretty confidently graph my function like this. Okay, you might even label this point 4, 7 since you found it. You might as well show, I know that we're going through 4, 7. And with these intercepts, make sure they're really clear with your crosses. You might also label them with coordinates like 0, 1, just to show that you do understand exactly where they are. And the last thing I should do is always label my function with its equation. Okay, so we've done everything. So that's part C, that last part. And you can use, this one's allowing you to use technology to help sketch the function. But keep in mind, you need to be able to sketch something like that without technology as well. So, after all that, basically the exercise you should work on now to check that you understand all this is exercise 2F. But before I do that, I might make a note. You might like to make these notes. So, to find a vertical asymptote, for the vertical asymptote, that's when the denominator equals 0. So, make the denominator equals 0. Oops. Solve for x. Then the equation of your asymptote is in the form x equals, and whatever your solution was in there. So if you got 5 in the end, it's x equals 5. To find a horizontal, asymptote, I'm going to give you a general example. So for y equals ax plus b over cx plus d, the horizontal asymptote is y equals a on c, or in other words, the coefficients of x on the numerator and denominator. If the numerator has no x term, put in 0x. So in other words, if you have y equals like b on cx plus d, then you make it y equals 0x plus b on cx plus d. So then the horizontal asymptote is y equals 0 on c, or in other words, just 0. Because they're the coefficients of x. Okay, and always make sure you have y equals whatever the number is, or x equals whatever the number is for the equations of your asymptotes, because otherwise they're not asymptotes and you'll lose marks. Okay, so I just wanted to summarize those two things about the asymptotes. And now, if we get back to where we were, the work to do now is exercise 2F. So please try a few questions of those.